Okay, in order to review Newton's second law, which we did in the lab on Wednesday, and just to practice the math we figured out, it's probably important to review Newton's first law. Newton's first law is sometimes known as the law of inertia, and it basically says that in order for an object to move, a force needs to be applied to it. Or in order to change an object's motion, a force needs to be applied for it. So we worked on the net force, right, the force that's left over after everything else is canceled out. His second law goes into more description about how to explain the law, the first law of inertia that says a force applies to a motion. So how much will the motion change depending on how much force you have and how much the mass of the object is. So what we figured out after graphing the motion of those cars is that the force is directly related to the speed, or the speed is directly related to the force, but it's inversely related to the mass. So we came up with this equation of acceleration equals force divided by mass. So if we doubled the force, the speed of the car was going to double. If we doubled the mass, right, the acceleration was going to be cut in half. So these are the different versions. If you wanted to write down the triangle, you could write it down right as force, acceleration, and mass. Okay, force is measured in newtons, mass is measured in kilograms, acceleration is measured in meters per second squared. All right, so to do the first one, right, the first thing you have to do is find what you're looking for. So what is the acceleration? So that's what I'm looking for, of a 2,000 kilogram truck. So that's my mass. If a force of 4,200 newtons is applied to it. All right, so I'm looking for acceleration. So the equation is going to be force divided by mass. Now, a common mistake that everybody makes is they give you this one first, so they put this one on top, and they give you this one second, so you put it on bottom. So if you're solving this one, it would be acceleration equals force divided by mass. So that's going to be 4,200 newtons divided by 2,000 kilograms. Right? So when you plug that into your calculator, what you're going to end up with is 2.1, and the units for acceleration are meters per second squared. Right, just to work one more with you, so you can always pause, stop, go back. What is the acceleration of a 0.3 kilogram or 300 gram ball that is hit with a force of 25 newtons? So same thing again, I'm looking for acceleration, right? They give me mass, right, and they tell me the force. Okay, so acceleration is force divided by mass, so plug that into your calculator, right, and what you're going to get is 25 divided by 0.3, and it's going to come out to whatever your calculator says it comes out to. Right, just to get you to think about the third one, how much force is needed? So now they're asking a different question, right? How much force is needed to accelerate a 68 kilogram skier at 1.2 meters per second squared? Right, so I'm looking for force, so which one of these three equations are you going to use? Right, hopefully you didn't just wait for me to answer, but you're going to use this one, right? So force equals acceleration times mass. So this one doesn't matter which one you take first, you'll just take 68 times 1.2. Okay? If you need help, either ask Mr. Ragsdale or walk down the hall and ask Mrs. Conley if Mr. Ragsdale's busy, okay? Or find somebody in the class that can work on this. But you've got these 4 problems to work on, and when you're done, turn it in.